that you could have attempted by now. Some of you might have attempted or done. Some of us might not have started. But hopefully you've at least looked at things a little bit. Hi, come on in. I'm going to start today by just taking some questions from the homeworks. So if there was anything you ran into that you weren't sure what to do with or any of that, we will do some questions. Tommy.
So on homework 2, it was anyway.
Okay. Let's see. Homework 2.
Yeah, for the second part, like part B, that was 1. When we're like writing out the translation, is that just like age is greater than 0 for that answer this question?
Yes, that right? Yeah, that would be, that's what I'm looking for there. Exactly right. You have to help me. Taylor, roar like a lion. Roar like a lion. Like a lion in the jungle, the animal. No, but the sound they make is roar. Oh. No, I have another Taylor in another class apparently. Well, that's why you looked at me like, what is this person talking about? No, that makes much more sense as to your reaction to my reaction. Because my statement now makes no sense, and your reaction is perfectly reasonable. Taylor Myers. Thank you for correcting me. What is your question?
So for number 18 on homework 1.
Yeah.
I got like 12 are equal to 1.
Okay.
But it's like x is greater than 1 and x is less than 1. How do you graph that if they're both 1?
Fantastic question. Should we do that? So we have this, right? Okay. And then we break it up. And just as Taylor said, we have this. Oops. So if I draw this, I have 0 here. Here's 1. So this one, I have that inequality, right? And then we'll do this one in the green. So this one, I have that inequality. Is there any overlap here? No, right? Because even at 1, it's an open circle on each. So there's no place where these both overlap. Right? Now they're both pointing away from each other, correct? So this should be an or and not an and. So we can just write it like this. And just for the sake of argument, this is the same thing, just as x cannot equal 1. Which should make sense, right? If I want an absolute value to be greater than 0, the only value that absolute value can't take is 0, which happens specifically when x is equal to 1. Is that okay? Okay. Mackenzie. Almost went the other M word. Sure. Number 14 is that stuff. Where's that snipping tool at? Is that one of those things that I have here? Maybe here? All right, well, we'll just do it the old-fashioned way. Okay. 9 minus 2x equals 10 plus 3x. That's it, right? Did I copy that down correctly? Which 3x? The first one. Thank you. Now we're good. double check real quick. Not that I don't trust you, but I don't trust myself. Okay. All right. So the first thing I'd want to do is to isolate the absolute value part. That's already done. Everybody agree? So we go right to splitting. So far, so good? Okay. Let's move the x's all into one side and the other stuff onto the other. So here I'll subtract 10 and then add 2x. So I have -1 is equal to 5x. And on this one, let's say I subtract 10 and add 2x. Oh my goodness, Kenzie. Yeah, cheapers, creepers. Woo! Okay, so I have 19 is equal to -x. That's better. So I have 1/5 is equal to x, and x is equal to -19. Is everybody so far so good? Let's check this. Rather than doing this check by hand, let's do it on the calculator, right? We mentioned that we could do that the other day, just for a change of pace. So I'll fire up my old calculator, and I'm just going to plug each side into a separate line on my calculator and evaluate and see if I get the same number. Okay. So to get the absolute value symbol here, I press the math button and then go over to the number command, or the number option, I should say. And I want the ABS. And then I can do 9 minus 2 times. And then I'm just going to type in -1/5 as like -1 divided by 5. Everybody okay here? So that gives me 9.4. Then I'll do the other side. So I have 10 plus 3 times -1/5, which also gives me 9.4. So that answer looks good to me. Mackenzie, you good so far? Okay. Now we'll go back and do 19s. So here's a nice little handy trick with your calculator. If you press second and then the enter button, it gives you the line that you just typed in before. And if you press it another time, it'll give you the line you typed in before that. So now I can just go back and edit and replace -1/5 with -19. And if I do the same thing again, I can go back and again replace the -9 or 1/5 with -19. And there, those don't work. Right, one I got positive 47, the other I got -47. So I have just the one solution of -1/5. Are you happy with that? Amy. I mean, I would happy to tell you them if I had them written down. So what's that one gotta be? Well, 23 would technically be no solution, right? Because you can't have a number that's coming out of the absolute value that's less than -25. 24, you can only have one number that's less than or equal to, for an absolute value to be less than or equal to 0. So it's basically just the solution to that absolute value equal to 0. So you could just set that equal to 0 and solve, and that one answer is your only answer. I guess, yeah. And then the last one we can really do. So that one you should get 2 answers. that should be an or inequality. To be like what? It's x is greater than 9, period. Because you get the same thing twice, right? Oh no, wait a minute. This should be, you'd get x is greater than 9 and then x is less than 9. Right? Because you have to, even when you do the split, you have the inequality symbol flip. Is that okay? Yeah, you're welcome. Anybody else? Mackenzie, is that okay?
So on homework 2, when you're writing the description, like to describe the transformation, would you still have to write like no reflection across the y-axis?
If it doesn't happen, I don't need you to write it down.
Okay.
So you only need to write down things that are happening. So like if there is a reflection or there is a stretch or shrink or there is a shift left or right or there is a shift up and down. If it's none, I don't need you to write down. It's not wrong to do it, but I wouldn't grade you down for not doing it. Is that cool? Okay. Yes, what's your name though? Loretta Alonzo. Number 20, you say. Okay. 1/7 y plus 2 minus 5 greater than. 1/7 y plus 2 minus 5 is greater than 1. Greater than 3. So this is number 20. Okay. Let's start by adding 5 to both sides. You good with that? I'll take from your silence that you were. And then we'll split this into 2 pieces. And we have to remember with that piece that we flip the inequality symbol and negate the right-hand side. So I'll subtract 2 from both sides. And then we'll divide by 1/7, or what I think would be easier in this situation is to think about it as a multiplication of the reciprocal. In this case, just multiplying both sides by 7. So that's the OR situation. So I have y is less than -70 or y is greater than 42. Did you feel good there? Yeah, no problem. Amy. Homework 2, number 3. The transformation? Okay. 2x plus 1. So my values for a is 2, my h is 1, and my k is 0, right? So the map that I make every time, x plus h, a y plus k. Right, so there's nothing being added on to the end outside of the absolute value. So k is definitely 0. So then I can just take my 3 key points and transform them. So I have negative 1 minus 1 times 2 times, and then 2 times 1. Then I have 0 minus 1, and then 2 times 0. And I have 1 minus 1, and then 2 times 1. Whoa there. So that gives me negative 2, 2. And then negative 1, 0. And then 0, 2. Is that okay? Yeah. And you're good like plotting those and drawing the picture, right? Yeah, that's no big deal. Yeah, of course. Doritos.
Can you do number 4 on homework 1? I just need like a visual of the story and I'm still kind of confused.
Sure. X minus 5 is equal to 3. Sure. Let me double check, because I don't trust myself to write anything down right. There we go. Okay, so you're right. The first thing we want to do is to isolate the absolute value. It's already isolated, right? There's nothing that we need to do, so we can go straight to the split. So the first split, all I do is drop the absolute values. And the second split, I drop the absolute values and negate the right-hand side. And then I just solve each of these two separately. So I add 5 to both sides, and then I add 5 to both sides. And we should check real quick, but this one I won't even bother to write out the check because it's pretty easy to do in our head. 8 minus 5 is 3, so that works. And then 2 minus 5 is negative 3, but the absolute value of that is positive 3, so that one works also.
Okay.
Is that good?
Yeah.
Okay.
And for the homework, is it okay if like I do the work on a separate notebook and then put the answers on here?
Yeah, just take a picture of what you did of your work and drag it into OneNote. Do you know what I mean? Mm-hmm. Okay. Yeah, if you do that, that's perfectly fine. You don't have to do your work in OneNote. Just your separate sheet of paper work, just drag it in there for me so I can look at it. Okay. Yeah, no problem. Good questions. What do you guys think? Feel a little better? How did these first two go? Pretty good? More or less? Easier than last chapter, I hope? At least more familiar feeling, right? We can argue about what hard or easy means, but familiar, you guys know what that means. Okay. So we'll finish up chapter 2 here today. So there's 2 more topics that we want to talk about. So the first topic we'll talk about is graphing absolute value inequalities in 2 variables. What that means is we're just going to be graphing things like y is less than negative 2, x plus 1 minus 3. It's something like this. Now, the procedure for graphing something like this and just graphing an absolute value function is very similar. In fact, it's going to be identical until there's 2 little things at the very end that differ, but it's largely the exact same process. So we'll just start by pretending that we have y equals instead of an inequality. So we're just going to pretend that we have the in a function instead of an inequality. We'll identify our values for a, h, and k. And just like before, we'll create our function map. And use that to transform our 3 key points. Again, whenever we're graphing an absolute value, it's the same 3 points that we're using. Everybody okay with this so far? So exactly the same so far as homework 2, right? Okay. So I'll go ahead and plot my 3 points here. There's that. But before I draw and connect these, this is one of the 2 things that are going to be a little bit different. So if I have a strict inequality, so either a less than or a greater than, I'm going to use a dashed line. And if I had an or equal to inequality, I'm going to draw a solid line. So because I have the less than inequality, I'm going to use a dashed line here. Everybody okay with that? I mean, technically speaking, they should be open. I'm not going to be that picky, though. But that's an excellent question, Mackenzie. So you're 100% technically correct that those should be open points, but I wouldn't be that picky on you or for you guys. Because especially once you draw the dashed line in, it's tough to tell whether the thing was actually opened or closed. You know what I mean? And I will assume that like having the dashed line there overrides the filled in point. So I'm not going to be too picky about that. Although you are 100% correct. And the second thing, so if I have a greater than or equal to, we're going to shade above the line. And if it's a less than or equal to, we're going to shade below the graph. So here I have a less than, so I should shade below. So there's my shading. And that's it. What do you guys think? Not a big deal, right? Really not considerably different than graphing from last time. You just have to remember drawing your line either solid or dashed, and then to do your shading either above or below, which all of those decisions are made by the type of inequality you have. Let's do one more, and then we'll move on to the next thing. Sound okay? So let's say we want to graph the inequality y is less than or equal to 2 times the absolute value of x minus 5. So just like before, we'll start out by writing our values for a, h, and k. So in this case, that's 2, 0, and negative 5. Everybody okay there? We'll write our transformation map. And we'll take our 3 key points and transform them. Everybody's okay to hear? No big deal, right? Same thing that we did yesterday or last time. Keep saying yesterday, guys. Okay. So let's see. 1, 2, 3, 4, 5. 1, 1. Okay, so I have 1, negative 3, 0, negative 5, and 1, negative 3. Now, because this was an or equal to inequality, I'm going to draw a solid line. And because it was a less than or equal to, I'm going to shade below. Everybody feel good? So those should be pretty easy, right? Or at least no more difficult than the graphing ones were. Whether you want to call it easy or hard, I guess, is a matter of opinion, but it's not really any more complicated than that. Do we feel okay with that? Okay. So the next thing that we'll talk about is modeling. So the idea here is I want to go from a graph or some information about a graph back to my equation. So the idea here is that we're going to go from a graph back to an equation, or some information about the graph and back to an equation. So let's look at an example. So let's say we have this graph here. Make that a little bigger. So I remember that any absolute value graph can be written in this form, right? Everybody's good with that? We remember that? I also remember something special about the absolute value graph is that the vertex that point on the absolute value graph is always at the coordinate h comma k. I remember that as well. For me to answer this question, I need to figure out the value for a, for h, and for k. If I can figure out those three values, then I'm done. Everybody agree? Well, figuring out h and k is really easy because I can just go and locate the vertex. And in this case, I can read that its y coordinate is -4 and its x coordinate is -3. So I know the h is -3 and the k is -4. Because the vertex always has coordinate h comma k. So I can always do that. The h and k are easy to get. Everybody's good there. So that leaves me just having to find k. K is going to be a little bit more complicated, but not too bad. I'm sorry, a. Yes, thank you. Leaves me just with a to find. So what I'm going to do is I'm going to identify any other point on my graph. So in particular, I like to use things that I can tell are whole number coordinates that I know I don't have to estimate on. So for example, here, 2, 0 looks like a good one because I can pretty easily tell just by looking at the graph that that's the coordinate 2, 0. As opposed, say, like trying to pick this point over here, which I'm not really sure what that would be. You know what I mean? So I'm going to try to find something that I can tell is a whole numbered point where I can't have screwed up any estimation. And this point here is like an x comma y, right? So what I'm going to do is I'm going to take this value for y and plug it in for y. And this value for x and plug it in for x. And since I already know h and k, I now have everything in the equation except for a, which I can solve for algebraically. So I can say 2 is equal to a times 0 minus -3 minus 4. So I wrote minus and negative. You could have just written +3. That's fine too. No big deal. It is the same thing. So 0 minus a -3 is just 3, and the absolute value of 3 is 3. And then if I add 4 to both sides and divide by 3, I get that a is 2. Is everybody okay there? So now I have everything I need. I have h, k, and a. So all it's left is for me to put it all together. So y equals a times x minus h plus k. What do you think there? Not too bad, right? Does this remind you of anything that you did in Algebra 1? It should kind of remind us when we were given 2 points and asked to write the equation for a line. Right? When you do that, you use the 2 points to find the slope, and then you plug one of the 2 points in to find the y-intercept. You guys kind of remember doing that in Algebra 1? That was modeling for a linear function. This is the same process, but because the function type is different, the mechanics are a little bit different, even though it's the same procedure or the same skill. So there should be some similarities. It should feel similar and familiar. Is everybody okay there? Let's give you guys a graph and let you try one of these on your own. So I'll give you guys a few minutes to do one, and then we'll kind of come back together and walk through it. But I think that it's helpful to, have a chance to try one of these or whatever, right? And I am going to put some grid lines on here because I know that especially if you're sitting kind of at the back, it's tough to see, like if you're trying to trace back and see the values, like where things are intersecting or whatever, you know, like without having a finger to touch to kind of trace back to the X or Y axis, it's not very realistic for you to do that. So I'm going to put some grid lines on this graph. And that's awful small. Let's make that a little bit bigger. That should be at least realistic to read, right? At least if you're in the front half of the class. Those of you guys in the back, I apologize. I'm doing the best I can, but I can only make the projection so big. You know what I mean, guys? Bring your opera glasses next time. You know what I'm talking about?
Yeah.
Those little like things you hold like this when they're at the sitting in the balcony in the opera. I'll see if I can make this a little bigger. It's probably about as good as I can do, but that should be fairly realistic unless you're got some really kind of pukey eyeballs. So again, take your time. We'll let you guys work on this for, I don't know, 5-6 minutes or something. Probably won't need that long for everybody, but give you a chance to play around with it. Another couple of minutes, I'll write down the answer before we start going through it. So those of you that finish quickly at least can check your answer. And if there's a little oopsie daisy, you can go back and spend some time looking for it while everybody's still finishing up. Or if you're still finishing up when I write it up there, you can go and, you know, check your parts to see if you've gotten, how far you've gotten, and if you still, if you need to do anything more. You know what I mean? Oh my goodness. So I wrote the equation there, that final answer down at the bottom. We'll go through how I got that here in another couple of minutes, but I have seen some people act like they're done writing, so I figured I'd put it up there and let them check. Yes, sir?
In the base equation, is it x minus 8?
Yes. What do you think? We ready to kind of walk through this? Speak now or forever hold your peace. All right. So I'm going to make this a little bit small. Oh boy. Just wanted to make that a little bit smaller so I could write off to the side. So first thing I observe is that h is -1 and k is +3 because of the location of the vertex. And now for my other point, I'm going to look for places where I have grid lines intersecting. So like here I have the grid lines intersecting. That looks like the point 1/2, 1. Or here it looks like I have grid lines intersecting. That looks like 2, -1. Or say here it looks like I have 3.5, -3, etc. I'm going to bypass anything where the graph isn't going through the intersection of two of these grid lines, because I don't want to estimate this because I need to have the exact coordinate or this does not work. Is everybody okay with that? Okay. So given all of these options, and again, there would have been options over here. I'm going to pick this one because it has whole numbers in it, and I don't have to monkey around with decimals or fractions, which is what I'd prefer. Since I have all these choices to make, let's make a choice where our life gets easier rather than harder. My life's hard enough. So there's my x and my y. So now I can go back to my original equation and plug everything in to solve for a. So -1 is equal to a times 2 minus negative plus 3. So when I subtract the 3 over, I get -4. 2 minus a -1 is 3, and the absolute value of 3 is just 3. And when I divide both sides by 3, I get a is equal to 4/3. So that gives me everything I need. When I plug it all back in, I get -4/3, x plus 1 plus 3. How do you guys feel on that? Not bad, right? Okay. What if instead of giving you a whole graph to pick from, I just give you some specific information? Okay, so let's say we ask you to write the absolute value function that passes through the point 3/2, 7/3, and has the vertex -3, 5/4. Is this any different than the previous problem? No. What's the only irritating part about this example? We're stuck having to use these fractions because we don't know any other points other than the ones that are given to us. So we'd have to use these ones that have crummy numbers attached to it. But that's okay. It's just fractions. So right away, I know that my h is -3 and my k is 5/4. And then this is my x and y. Everybody's good with how I determine that? So I can say 7/3 is equal to a times the absolute value of x minus h, so minus a negative is a plus k. Everybody okay there? So we'll start by subtracting 5/4 from both sides. To do that, to subtract those two things, we need to make a common denominator. So I'll multiply 7/3 by 4/4. And 5/4 I'll multiply by 3/3. So I really get 28/12 and -15/12. So that's going to give me, when I combine like terms, 13 over 12. Is everybody okay there? Okay. Next, I'm going to do the 3 over 2 plus 3. Again, I'll make a common denominator. 3 is just 6 over 2. So I really have 9 over 2 there. And the absolute value of 9 over 2 is just 9 over 2. And now I'll divide both sides by 9 over 2, or what's probably going to be a much easier way of thinking about it is just to multiply both sides by the reciprocal. Everybody's okay there? Now I think the easiest way to do this multiplication is to reduce first. So I notice that the 2 and the 12 both have a factor of 2 in them, so I can reduce those. And now when I multiply across, 1 times 13 is 13, 9 times 6 is 54, and that's equal to my A. Yes, sir?
Can we use the very long fractions to decimals?
What if they're not terminating? If they're not terminating decimals, you're going to get in, if you're going to get to the end and your value for A is not going to be correct. So I would say there's a difference between saying, like, if A is 1/3 and you wrote like 0.3 or 0.33 or 0.333, still not the same thing, right? So that's the place where I would say you're liable to run into some problems, and why it's better to hang on to all those fractions. Yes, sir. Of course. Just to point out to you guys, though, also, if you're ever unsure about your fraction arithmetic, you can always use your graphing calculator to kind of double check these things. So for example, if I want to do 7/3 minus 5/4, if I press alpha and y equals, that opens up the fractions menu. And if I pick that n over d command, I can do like 7 over 3, just like it appears on my sheet of paper. And then minus alpha y equals n over d, 5 over 4, and hit enter, and it'll give me exactly what I'm looking for, still as a fraction, which is awful nice. So again, you should be able to deal with these fractions, and maybe it's a little tedious, right? But it's not the end of the world. And we always have our graphing calculator you can double check your operations with, so that you don't really do something silly and, like just add numerators and denominators with no common denominator or something. Like the calculator will help you check all that to be like, oh, do I add both the numerators and denominators? Do I need a common denominator? Like try it the way you think and then check it with your calculator and be like, oh, that wasn't the way you did it. Anyway, so we found our value for A, and now we just need to put everything back together, right? So A times absolute value of x minus h plus k, which was, what was it, 5/4 or something? I need to go back and look. Plus 5/4. Is everybody okay there? So again, no different in the procedure from what we did before. Just the numbers were irritating. But like not so irritating that they weren't capable to deal with. It's slow, right? And maybe tedious. But that's okay. It's good refresher. It's not like I'm going to give you an entire test full of everything has nasty fractions in it. But if you get 1 or 2 in there with some nasty fractions, you should be able to cope with that. You know what I mean, Amy? Yeah. So I think the easiest way is if you use the alpha button and then the y equals. That opens up this little shortcut to the fractions menu. And almost always the one that you're going to want to use is this numerator over denominator one. And you can just type it in exactly as your fraction looks like on your sheet of paper. Sergio.
Can you just click the math button and just go over the fraction? That was good.
Yes. Yes. Tommy?
How do you get the absolute value one again?
So to get the absolute value command, you press math, and then you go over to the number tab, and then ABS is the absolute value command. So it'll put the absolute value bars right in there for you. And now I have absolute value in a fraction, which is weird, but whatever. But yeah, there's more than one way to skin a fraction. I'm just going to tell you the way that I think makes life easiest because it looks like what you write on your sheet of paper. But certainly what you're describing doing works as well. What do you guys think? That's it for this chapter. That's all I got. So if you look at your content library on OneNote, or if you look at PowerSchool, you'll see that for Sunday I have 4 homework assignments that I'm looking for. So there's the solving and graphing ones that you guys sound like you've already worked on a bit. There's the other graphing one with the inequalities on it. There's 4 questions there. That shouldn't be bad. And then there's 4 of these modeling questions. Again, that shouldn't be too bad. And that's it for Sunday. Next week, on Tuesday, we'll take like just a day to ask questions, and you can work on the test review in class and ask any specific individual questions you might have. That's it for that day. Maybe we'll do a homework quiz. We haven't done yet one of those for this chapter yet. Should probably do that. I shouldn't have told you that though, huh? And then we'll take the test on Thursday for chapter 2. Everybody okay with that plan? And time remaining, we'll start chapter 3 stuff. I think that this one won't take too long for you guys. But the rest of today, you can spend kind of working on the homework or asking specific questions or getting caught up on whatever it is you need to get caught up on. So you guys still have 30 minutes almost. So